Hello. Today I'll be doing a calculus problem, a continuation to what I did yesterday. It's a volume of a solid of revolution, and my solid is bounded by y equals x squared here and y equals x plus 2. I went ahead and did the graph of the two functions. To do the graph of the two functions is really not very difficult. You have y equals x squared. This is y equals x squared, and y equals x plus 2. It's important to find the intersection points first before you attempt to draw the graph. To do the intersection points, you solve this simultaneous equation. In other words, you set x squared to x plus 2, set them equal, and then you solve, and that will give you x equals -1 and x equals 2. It's not really a difficult quadratic function. And so you have this region to revolve, and the region, let me see if I can shade it up a little bit. So that's the region that we're revolving about the line x equals -1, and this is the line x equals -1. This is x equals -1. So we're revolving it about the line x equals -1. All right, so essentially this, when revolved about that line, will give us a three-dimensional object. Okay, that's a solid of revolution, a three-dimensional object. One thing we can see here is that the region has is simpler from the vertical point of view. I call it a vertically simple region. What I mean by that is we see a clear top function and a clear bottom function to the region, as opposed to a right side and left side. As you can see, the left side of the region is a patch of two curves, this linear piece and this left wing of the quadratic piece. Well, of course, the right side is the quadratic expression on the right side. It would give us a little bit of a problem if we look at it from a horizontal point of view. So I like to see it from the vertical point of view. So what I do here is I pick an X and draw a segment, a vertical segment in my region, and revolve this vertical segment about my axis to get a cylinder. Once I get the cylinder, in other words, I'm using the cylindrical shell method, then I find the volume of the surface area of the cylinder and calculate the integral of that surface area. So I'm just estimating that this is that far out, and this is that far out from this line, and I'm trying to draw the mirror image of my vertical segment, kind of like here. And now my cylinder would look like so. It will kind of look like that. Okay, so I have the cylinder. So all I have to do is calculate the surface area of the cylinder, the lateral surface area of the cylinder, and then integrate from x equals -1 to x equals 2. Okay, so this point is my x. So at the given x, I made a segment, revolve the segment about the axis of revolution, which is this one here. Okay, this one. And then I get a cylinder and find the volume of the cylinder. To get the volume of the cylinder, I need a couple of things. One, I need the height. And two, I need the radius. Okay, the height is at x, h is x plus 2 minus x squared. X plus 2 minus x squared. The reason is the distance from the x-axis to the tip of the segment is x plus 2. Okay, at a given x, because that line is y equals x plus 2. The distance from the x-axis to the bottom of the segment is x squared. So that segment is x plus 2 minus x squared. And now let's calculate the radius. The radius is that distance, which is x plus 1. This is actually true even if x is on this side of the y-axis. If it was on this side of the y-axis, it would be a negative number, and then you add that negative number to 1, it will give you whatever that distance would be. Okay, so it is x plus 1, and now we remember that the surface area of a cylinder is 2 pi rh. So to get the volume, what we're going to do is calculate the integral of the surface area, which is 2 pi rh. Now with respect to x, because we picked an x, and x could go from -1 all the way to 2. So with respect to x, from -1 to 2, I have 2 pi times the integral from -1 to 2. R is x plus 1, and h is x plus 2 minus x squared dx. And I went ahead and FOILed this expression, multiplied each by x and each by 1 and added up, and what I got is negative x cubed plus 3x plus 2. Integrate that with respect to x, and that gives us 2 pi times negative x to the fourth over 4 plus 3x squared over 2 plus 2x. Evaluate that from -1 to 2, and you plug in 2 for x. Let me see, I can make a big square bracket. You plug in 2, you get negative 2 squared. 2 squared is 16. 16 over 4 is -4. Plus, that gives us 6, I guess, and this is a 4. Minus, plug in -1, that will give us -1/4, and 3/2 minus 2, or 2 pi. This is 6 plus 1/4 minus 3/2 plus 2. If you take the common denominator of 4 and add it up, you end up getting 27 over 4, if my calculation is right. 27 over 4. So that gives you 27 over 2 pi. The 2, I cancelled it. That gives me 27 over 2 pi. And that's the volume of my solid. Okay? To recap quickly, I have a region bounded by a linear function y equals x plus 2 and a quadratic function y equals x squared. The expressions are given in terms of x, so the graphs functions are given as y equals f of x, y equals g of x. So x is the independent variable and y is the dependent variable. So it makes more sense to take x's and work in terms of x. It makes life easier. So you pick an x and make a segment in your region, revolve the segment, and because the segment is parallel to your axis of revolution, that makes a cylinder, and find the area, surface area of the cylinder. That's 2 pi rh. To do that, you need the value of h and the value of r in terms of x, and then that's the integral to calculate. You compute the integral and you get the volume. I hope this helps. I'll probably do more videos on techniques of integration or something of that nature. Thank you. Goodbye.